cards now?
Yep.
Alrighty, sound cards, digital modes. So the first time I gave this talk was about a year ago, and there were lots of questions. And then, of course, from the questions, I decided to change the talk, add this, subtract that. It's usually more adding than subtracting, but, change it. And then after giving this talk about, what I've given it maybe 6 or 7 times now, I sort of get a feel for where the bumps are, meaning where there's a little like, what? You sure that's right? So I wanted to start out by just showing some of the typical gadgets that generate, can generate sounds that can be converted in a radio to, a digital mode. So there's a variety. Someone asked me, well, what's the best sound card? Well, there's no answer to that. What's the best car? What's the best food? What's the best anything? Do you need a really expensive sound card? I've often heard that question. And the answer is no. For most of unless you're doing moon bounce, no. $5 sound card will work. The sound chips in your own laptop will work fine. So I thought what might be fun is if we start out with a quiz. So here's my quiz. Can you identify some sound cards modes if I just play them? So you don't know what I'm doing here on my side here, but I'm going to just play some sounds, and you tell me if you can figure out what's the mode. It's like Name That Tune. That's an American kind of game show. Name That Tune. So I'm going to start out with some real easy ones, okay? So are we up for this?
Yep.
All right. Hands free. I didn't say
Sounds like Sandra in a relaxed mode.
Did you copy my call, Sandra?
Yes, we did. CQ from K3EUI.
All righty. So how did I make that? Well, I have a program called FLDIGI. It's running on Windows 10. And it can send a whole variety of modes, including CW. Now, I'm not sending this on a radio. I'm just making the sound. So it's coming out of the sound card and going into a little speaker amplifier. So I think, everyone knows what Morse code sounds like. Here's another one that some of you probably have heard. I'm still sending CQ, K3EUI. I'm always going to send the same thing. So, name that mode.
RTTY,
radio teletype. So I set the tones at about 900 and 1100 hertz. If I set it up where often you hear it, 2100, that's an awfully high pitch. And my wife downstairs would start complaining, like, what is that noise? Radio teletype, well, that came out, 50, 60, 70 years ago, easy way to communicate using the way I'm doing it. It's 2 sound waves. The 2 sound waves are a little bit separated in frequency, and we'll take a look at that. Here's one of the more modern ones, sort of. You'll probably recognize this sound. Let me set it for a little higher pitch. All right. Now, same thing. CQ 3 times, DE, K3, EUI 3 times, K, over.
Yes.
So that mode was what?
PSK.
PSK 31. That's kind of a warbly sound. It's kind of a unique sound. I'm a former bassoon player. It's not very pleasant to listen to that. It's like a little bit of a fuzziness to those sounds. But very, very efficient. And we'll take a look at why. PSK 31. And that came out when? Late 1990s, maybe? So about 20, 25 years ago. The sound is created in a sound card, right? And the sound can go into your radio, mic jack, data jack, and then it's just converted to a radio frequency. And at the other end, your receiver catches the RF, converts it back to sound, sends it back into your computer via another sound card. So it's really just sound talking to sound. The radio is just the means to get the sound from one, computer to the other. Does this work well on single sideband? Sure. Does it work well on AM? Sure. Does it work well on FM? Absolutely sure. It's just that usually FM takes up more bandwidth, so we don't play with the FM modes on, 20 meters or 40 meters. But yeah, it works. Does it work over a repeater? Very well. We do a lot of practice nets on a 2-meter repeater. It's just sound. That's all. So let me try a different one. This is a very famous one here in America on the 40-meter nets. Listen to the beginning and to the end, and that's a clue. I'm still sending CQ 3 times. Do you hear the end? Doody, doody, and the beginning. Doody, doody, boo beep, boo beep. So what mode was that?
Sounds like slow scan.
Slow scan, yeah.
No, it wasn't slow scan, although, yeah, slow scan does have, sounds that vary in pitch. That was called Olivia.
Oh.
Olivia. Olivia always begins with the low tone, then the high tone, then the low and the high. So it defines the boundaries of the sounds. And then depending on the mode, there may be 8 tones between or 16 or... So Olivia 8500 means there's 8 tones, 500 hertz wide. Boo beep, boo beep. Let me play that again. It's kind of pretty. I'm going to move it to a lower pitch so it's not quite so annoying to hear. And you're just picking it up with my Zoom microphone.
Yeah.
That's a lot of sound for just CQ, isn't it? Still going, dude. It's so fun. CQ, CQ 3 times. Why did that take so long? Oh, so Olivia is very robust, meaning it'll get through the noise, but it's very slow. It's like sending, slower CW. It's only about 30 words a minute, which is really slow for digital modes. Let's go to the other extreme. Olivia 32 1K. So here's 32 sounds. 32 different tones, each of a unique pitch. Oh, only one is sent at a time. Olivia never sends 2 tones together. That would create all kinds of harmonics and mess. Here's 32 different tones that are spread out over 1 kilohertz. So, it would occupy a full kilohertz on 20 or 40 meters. Nobody would want to do this. You wouldn't make many friends. But here's what it sounds like. I'm going to move it up a little higher here. Olivia 32 1K. I'm going to stop it. I'm getting a headache from that. I'm still setting CQ, CQ. So why is it a really good question? Why are there so many digital modes? That's a good question. Why are there so many languages on planet Earth? I don't know. Different modes serve different needs. Some are a little more robust. Every year there's another 2 or 3 different modes that come out. The Joe Taylor modes, they're very specific. So here's one of my favorites. Again, a former bassoon and saxophone player. It's called Thor. I mean, who wouldn't like a mode called Thor? Thor, Thor. This one is Thor 22. 22 tones per second. That's the 22 baud. And there are 18 separate sounds, only one at a time. So this is pretty. I'm still sending CQ. Thor 22. .500 hertz wide. So it's just a little wider than a typical radio teletype RTTY signal. Far, far, far more robust than radio teletype. This thing really gets through the noise. It has a lot of what's called forward air correction, has a lot of redundancy, and it's just fun to listen to. All right, so I think that's enough. So there are all kinds of different modes for different purposes. Some work better on 40 meters, some work better at night. Some take up too much space, and then you're called, a hog. You don't need 2 kilohertz to get, talk to someone on a digital mode. So here's the plan. I'll take a look at the hardware, then I'll take a look at the modulation methods. We'll take a deeper dive into the modes, and then probably next week, if you invite me back next week, I'll take a look at a shootout between WinLink and NBEMS. They're both the emergency communication modes. So first, the hardware. I thought, well, let me show you a simple picture. This really is one of my stations here. It's a Chester County, Pennsylvania Go kit. That's an emergency kit. So right now I have it set up on my shelf. So here's the radio and a little ICOM 706. It's about 15 years old. Above that, a Pactor TNC. It can actually do Pactor and packet. Now that's what we call a terminal node controller, TNC. Special piece of hardware that can send 2 digital modes really well, Pactor and packet. It connects to a data jack in the back of the radio. To the left of that, a little simple SignaLink. There are gazillions of these things. They're just external sound cards, so you don't have to use your computer sound card, which may be tied up with email and Windows sounds and all kinds of stuff. To the left of that, a little MFJ antenna tuner. To the left of that, or above, a little speaker. So all this fits in a box. I have a battery, and I can set this up portable with either a 2-meter antenna, 440 antenna, a long wire, and I have a little antenna tuner. So probably in a half hour, I can set up anywhere in the county that I live and get communications from 2 miles to 200 miles pretty easily. If I get on 40 meters, I can talk to stations, with digital modes, hundreds or thousands of miles away. So it's kind of an all-purpose little MCOM station. Not with a very sophisticated radio by today's standards, but that little radio works 160 through 70 centimeters, all modes. It doesn't do anything really well, but it does everything well enough. So I thought, well, that's interesting. You don't need to spend a lot of money on big fancy, new big digital radios. Everything in this picture, if I added up, would be maybe $1,000. So what do you need? Well, you obviously need a radio. What's important isn't that it's a fancy display and, modern and SDR and everything. What's really important is it has a frequency stability. You don't want the radio to be drifting in frequency. So some of the old tube gear, you turn it on, and I used to have some of these, the radio would drift, but if you were on AM or, CW, who cares? But drifting kills the digital modes. So you have some way to get, the information in and out of the radio. Well, every radio has a mic jack, and most of them today have a data jack. And every radio has a speaker jack or a headphone jack, so that's a simple way of getting sound. We're talking about analog sound now. There's nothing digital about this. It's analog sound. It's only digital when it's in your computer. So you need a sound card. Well, what's that doing? Well, that's the key. That converts what's digitally produced in your computer, zeros and ones, into DD, analog audio. So the combination of a radio and a sound card gives you a lot of flexibility. I would say a lot more than if you had like a CW key, because that can just make an RF wave go on and off. That's all CW is. So you need an input and output. You need a way to tell your transmitter, okay, transmit it now. I push a button on my keyboard and my radio goes into transmit mode. How does that work? A PTT, push to talk, and a common ground cable. So it's really not very sophisticated. All of the stuff you can do with simple radios and simple sound cards. You don't need very expensive equipment. So the interface, all it has to do is not too much audio, not too little audio. Well, it sounds easy, but in practice it takes a little bit of experimenting to get just the Goldilocks amount of audio in and out of your radio. You need to be able to send. That's not so hard. A lot of radios today have CAT control, computer control. That's an easy way to do it. Some of them even have a Vox circuit, and you can use the sounds from the digimodes as a Vox signal, as if I were using a microphone. I can put my radio on phone and put a Vox button on, so as soon as I start talking, my radio transmits. You can do the same with digital cards. You don't really need the CAT control, but a lot of people like to do it on HF, because then you can click here, click there, and your radio shifts to a new frequency. So how did this start? Well, you know, the sound cards came out in the 1990s or so, and they kind of look like this, although this is a more modern one. You know, kind of a complicated series of, you know, chips and capacitors and, you know, plug-ins. And it started out as like an extra, and then people realized, or I guess the computer manufacturers realized this. A lot of people want sound, even if it's not for, you know, a ham radio purpose. So all kinds of gadgets were plug-in cards back in the 1990s. And now if I look at what's the simplest sound card, it might look like this, a little USB plug-in sound card. You can pick this up for like 10 bucks. What's inside of it? Not as many chips, but it works. Sound in, sound out. So it has the typical microphone and headphone in and out. I wouldn't say you'd play symphonic music over this, but it probably works well enough for all of the digital modes you would likely to do. Little volume control, a mute, and you know, it doesn't take up any room, doesn't take up any power, and you can plug this into any desktop or laptop through a USB. Very convenient. You don't usually worry about stereo. We're listening to sound and transmitting sound, but we don't need stereo. But most of these have what? Stereo output, left and a right channel. So the question is, do you want to use the left channel audio or the right channel audio, or maybe add them up? Whatever you want to do, the software has to enable you to do that. Here's the typical way a lot of people start out. You have a computer, but you don't want to use your computer sound card because you don't want to inadvertently transmit over, you know, a ham radio frequency. You've got mail. That'd be kind of annoying. So it might help if you have a sound card unique to radio needs. So these little SignaLinks and Rigblasters, and a lot of companies make these. They're standalone USB sound cards that you just devote for the ham radio applications. So that connects to the computer with one cable, USB cable. Oh, I should say, you guys know me. If you have a question, just, I won't see your picture. Don't raise your hand. Just press the space bar, unmute, and call out a question. Don't wait till the end, please. Okay? All right. So the SignaLink is just a little standalone sound card, USB. Not great fidelity. It's only one channel, the left channel. There is no right channel. That doesn't bother most of us. The output of that goes on a different cable, I'll show you, to your radio. Now that's the complicated one. Not all radios have the same kind of plug-in ports, or the pins are arranged differently. So the tricky thing is to get the transmit audio into your radio at the transmit socket, you know, the audio microphone socket. And the same thing going the other way. The speaker out of the radio's got to get into the sound card input. So the ins and the outs have to be wired correctly. But a simple thing, you know, series like this. Now in the newer ones, the SignaLink is built right into the radio. That is, the sound cards are built into the radios. So it alleviates, you know, getting a separate sound card. How do you make the thing transmit? How does a push to talk work? On a microphone, it's easy. You just push the talk. You know. On a key, it's easy. Just push down the key. Your radio transmits. So how do you get sound card modes to turn your radio from receive to transmit? Well, one way is just a few parts like this. You have a serial port on your computer, or maybe you have a USB to serial port converter, and you can use one of the common pins like RTS, DTR. And when that pin, the computer sets it high, meaning 12 volts, that 12 volts can go into a little transistor switch into the base. The transistor conducts, and your PTT gets grounded. It's the same as pushing the PTT on your microphone, except it's doing it, what, by a command on a software application. So you could build this for, you know, a couple dollars, or sometimes these are built into your sound card application things. So let's take a deeper dive into the SignaLink. US, they're about $100, maybe a little more than that. There are a lot of them used. So I see these at Hamfest now for like $20, $30. I guess people try it, they're not satisfied, they don't like it, so they get rid of it. Sort of like old D104 microphones. There are a ton of them out there now. My favorite microphone, I think I have 10 of them here. So, has a transmit knob, a receive knob, and a DLY, a delay knob. We'll talk about what that means. A very simple gadget. It's, you know, the size of your fist. I've got I've got 6 of them in my shack right now, attached to different radios in different ways. Here's the back, equally simple. The radio, here's the tricky one. The radio goes obviously to your radio, but where? It can go to your mic plug and speaker jack. It can go to a data socket. A lot of the newer radios have a data plug, 6-pin mini DIN, 8-pin. Some of the older ICOMs have 13 pins, but each pin has receive, transmit, push to talk, and a ground, and then some other stuff. The USB is obviously to your computer. The MON jack, that's kind of nice. You can plug in another set of headphones, and when you're sending a digital mode, you can hear what the sound is like. Now, you're not hearing out of your radio. It's not like that. You're just hearing what's coming out of your sound card going into the radio. But if that sounds bad, then there's something wrong with your RF. Monitor jack, they call it. Here's the inside of the thing. There's not many parts. Here's the smallest part right here. Well, that's the Texas Instrument chip. That's where the analog digital conversion gets going. And all these resistors and capacitors just support that. Here's the radio out. Here's a USB. So here's your 2 jacks. These things are the receive, transmit, and delay knobs in front. Of course, this is in a little box, as you see here. Here's an interesting part. It's a relay. Why do you need a relay? Because your PTT, when the SignaLink says, okay, here's enough audio, go to transmit, the relay closes the switch. It's just like you pushing the PTT button on your microphone. Here's a couple transformers. Why do you need those? Well, it's galvanic isolation between the input and output. Maybe you don't need that, but this is sort of safety. So you don't have a common ground between your sound card and your computer and your radio. Sometimes you get hum. These kind of alleviate the hum. Here's the critical part right here. What is this? The jumper block. And it says speaker, mic, PTT. They're all blank. So you have to connect these. Here's the tricky part. These little wires, you need a magnifying glass. You got to put the wires in the right jack. So for your radio, you can get the speaker and the mic and the PTT and the ground all hooked up in the proper cable to your radio. Switch radios, you got to open this up and switch all these wires. Here's a newer one, came out in 2018, but it still has this jumper block. A little better quality transformers, a little more better circuit actually, but it's like SignaLink 2. So here's the jumper block. Oh man, it looks so easy, and this is nice because it's color coded. It's not so nice. These are real small. You need real good, my bifocals, real good lenses here to get the wires in the right holes. Here's what a typical microphone connector looks like. Here's a typical data connector. And SignaLink, Tigertronics, the manufacturer, realized so many people were messing up these connections that they started to manufacture little blocks. You just plug this block into the right holes, and each block was designed for a certain specific radio. So you got the block for, the ICOM 22 radio, the Kenwood 44 radio, and you just plug them in. Now what's the problem? Well, these holes are pretty small, so what happens when you try to plug this in and you miss it by one block? So now they have another problem. Even though it's a plug-in, you got to plug it in the right pins. So that's really where most people go wrong. A good friend of mine, not very good eyesight, he bought one of these, set it up, plugged it in, wouldn't work, sent it back to Tigertronics. They looked at it. They said, we just plugged it into the wrong pins. You missed by one. So they, so many people were doing that Tigertronics made these little stickers that said, be careful, you got to plug into the right block, pin numbers. All right, so anyway, that makes this a little hard to set it up. Here's another gadget called a Rigblaster. These came out about 15, 20 years ago. Very clever gadget. This hooks up always to your microphone jack on your radio. Oh, no data jack. Well, in a way, the microphone is a data jack. Most of the modern microphone jacks have microphone in audio and speaker out audio, as well as a PTT, often a little, up-down VFO controls. So there are 8 pins in here, which means this thing can take your sound card audio from any source you want and send it into your radio's mic jack. Why would you want to do that? Oh, it's easy. Then you don't need to be in any other mode than phone. If I'm doing this on single sideband, the radio's on upper sideband or lower sideband. If I'm doing it on AM, the radio's on AM. There are no data modes. In other words, the sound is acting as though it's like your microphone. So what happens if I want to get on and use my microphone? Easy. Your microphone plugs in here, and when you pick up your own mic plugged into the Rigblaster and push the PTT button, it disengages the sound card. Very, very clever. So you can switch between talking and digital just by picking up your mic. And so the disadvantage here is what? Well, you got to be careful when you're feeding digital audio into a microphone jack. That's very sensitive, just a couple of millivolts. So the trick here is be careful you don't have any RF feedback, any hum, anything else. But it's behaving like a microphone. Very clever, very nice. You can transmit audio on left channel or right channel, or this is clever, both. Why would you want to do both? Never. But what it does is just with a resistor, add the left and right audio for one combined audio. It's like buying stereo headphones and plugging into a monaural jack. You just get, the identical sound on both sides. It also has a little Vox circuit, so you can use a COM port for PTT. So the output of this is a little more cleverly designed, I'd say. Here's a fancier one, a Rigblaster Advantage. I have one of these. I've loved it. It still plugs into your microphone jack. So basically it'll work with any radio that has a microphone jack, but internally you still have to design it for your radio. Transmit level, receive level, Vox delay. Vox delay is kind of interesting. What does that mean? When you stop talking or stop the digital sound, how long is it before your radio goes back to receive? There's an expression that sort of means the same thing. Hang time, sort of a basketball expression. You jump up and you're in the air for how long? So how long does it take to delay from when your transmission ends to your receiver comes back to life? CW operators like to call it what? Break-in speed, Sandra?
Yeah, that's right.
Yeah, break-in speed. So you're sending with your key, and as soon as your key is up, your radio goes right back to receive, or even between the dits and das. So a very clever device, a little more expensive, but it works well with any radio ever manufactured, as long as you have access to a microphone jack. Here's the back of it, and you can see it's a little more complicated than a SignaLink. The microphone means the cable that goes to your radio. Over here, the USB, computer connection. But over here, you can have a rig control on Kenwood radios, ICOM radios, speaker in and out, a separate PTT jack where you could put a foot switch. Very, very, it is very well made. West Mountain Radio is the manufacturer's name. They still have internal jumper blocks. I guess you can't avoid that because, there's no, the Yaesu, the ICOM, the Kenwood, the Elecraft radios. They all have different pins doing different things. Oh, man. So you still have these jumper blocks or plug-in modules. And you can see over here, if you look at this, that's pretty complicated looking. I've wired a few up, and one time I get a wire in the wrong place, and I go to transmit, nothing happens, and I check, and oh yeah, I got the PTT wire in the wrong socket or something. Usually I don't see smoke, so that part's good. Simple cat control on ICOM. I love the ICOM rigs. They're so intuitive. Here's a simple CIV, just one shielded cable. Here's a cute little box. I have one of these, and a couple of friends have one of these, called a Rigblaster No Mic. Well, no mic's a giveaway. There's no place to hook in your microphone. So they've done away with half of the circuitry. You do have sound card audio coming in. It says audio in. You do have a COM port. It's typical 9-pin, and that does your PTT, sending control. You have a little level adjust, volume, mic out, and audio out. So that's all you need. And in fact, I labeled this ICOM 8-pin mic, so I remember how inside there's a little jumper block. There's always jumper blocks. But man, this thing works well, but it works on an external sound card. Even on one of those little $5 USB sound cards. Works fine. So it's a simple way to get the sound from a sound card into your radio with some level of control and a PTT COM port. Very inexpensive too. And you can see by the size of the quarter, not much here. And I thought, well, let me try one of my really good sound cards. So I have a Sound Blaster. That sounds good. It's like a gaming sound card. But look at the output. They're all, phono jacks. This doesn't look like my radio connection likes these. So then I had to make up a cable that goes from the sound in and out here to my radio, so that was a little tricky. But this is a really well-built, well-designed, very low noise stereo sound card. It didn't do any better for me on the digital modes. Maybe if I was interested in moon bounce, where I wanted a really, really good sound card, I might, use one of these. And then along came a company called Masters Communications, and I know the owner of this, and he decided to make some sound cards that have a different sound chip. This is a C Media sound chip, not a Texas Instruments sound chip. And unlike the SignaLink, this has left and right, and it has amplifiers, and it has a Vox signal or a hardware PTT. It has gazillion ways to hook this up to your radio, and boy does it work well. And it's about the same price as a SignaLink. It's just another sound card, but one very carefully designed for ham radio needs. And there are others. MFJ makes a whole bunch of them. Rig Expert, I hear these are really good. I don't have one of these. But all these sound cards are doing is, making a way for your computer to generate the digital sound going into the sound card, coming out as an analog signal, and that going to a microphone or a data jack. So it's really pretty simple. I thought, well, what if I just hook my laptop audio right to my radio, forget all these interfaces? And I tried it, and it was awful. I mean, I just went from, speaker out on the laptop to microphone in. Too much audio, had hum. It was awful. And I thought, well, what if I try a little isolation transformer? This was a Radio Shack stereo, red and white. So I said, well, let's try the red for transmit and the white for receive audio. And I hooked these up carefully, and man, it worked well. So I realized, oh yeah, isolating the ground sometime is the clue. Really inexpensive. This is like $15, American. Although Radio Shack is gone. So, I miss Radio Shack. So new radios, they said, hey, let's build the sound card in the radio. So all the new radios now are coming out with sound cards built in, and very high quality ones. But here you're spending $1,000 for a radio, so you kind of expect it to have the sound card built in. A lot of friends of mine have this one or this one. They all don't bother with their old SignaLink, so they give me their old SignaLinks and I play with them. So now we want to talk about not the hardware but modulation. So let me stop and I just ask if anyone has a question on the hardware.
No. I think I have a collection like yours, Barry.
Well, people give them to me because they know I kind of collect them. I collect old Baud Anchor radios, all the tube radios. I finally had to get rid of them. D104 microphones. I think I've got 10 of them. Yeah, there's 6 in my shack right now. So usually, people didn't like it because it didn't, usually people don't like the digital modes because you have to type. I said, well, of course. If you don't enjoy typing, don't get on a mode where you have to type. So how do you get modulation? How do you get these sound card sounds into your radio? Well, you only have 3 choices, AM, FM, or PM. That's it. So what do these mean? All right, well, let's take a look at amplitude. That's easy. When the sound gets louder, the radio wave gets bigger or it gets turned on. So what you're changing by the sound is the amplitude of the RF wave. Well, we have a famous method of modulation called amplitude modulated voice. That's the old, the AM sound. But we have a digital version of this. So Sandra, what's the digital version of AM? I hear it's your favorite mode.
Press your space bar, Sandra.
You have to press the space bar. I'm putting you on the spot, Sandra. What's the famous digital mode that relies on amplitude shifting the sounds?
CW.
CW, you got it.
Yes.
All right, so if it's voice, you're changing the envelope of an AM signal. If it's voice on FM, you're changing not the amplitude, but the frequency, the spacing of the waves. So sending data can be on AM, FM, or PM. How do I send zeros and ones? Well, that's easy. I put a key. I press the key down and a radio wave goes out, CW. I just press it on and off and makes, the dits and dots. So zeros and ones are what? It's on and off, on and off, on and off. CW, Morse code. FM. Well, that's what RTTY is. RTTY changes D D D D D D D D D D D D D. You know, it's only 2 tones in RTTY. It's never both at the same time. Be careful here. That wouldn't work. It's either one tone D or the other tone D, but they have to be, you know, frequency spaced. Phase shift. I can't make sound of a phase shift. It's like a wobbly sound. Okay. So what do AM and CW have in common? Amplitude modulation and CW. I think I just asked that. They're both AM types of signals. How about Olivia and Thor and MFSK? And I didn't play FD8, but you probably have heard that. D D D D D D D D D. What do they all share in common? Their frequency shift information. That is the information. The modulation is embedded in the frequency of the sounds. D D D D D D D D D D. How about PSK, a new mode called Vera? 8PSK, it's also a new mode. MT63, that's been a lot. All of these are phase shift modes. So AM and CW, the information is in the amplitude of the RF wave. RTTY, Olivia, Thor, FT8, the information's in the frequency, the pitch, the audio pitch. But these are mostly constant amplitude sounds. And then PSK and Vera and so forth, they're phase shifts. So we're going to deep dive a little bit into these 3 types. So someone said to me last time, why do you want to use digital modes at all? I said, well, why do you pick up a microphone? I want to talk to someone. I want to communicate with someone. So I'm thinking, what are the different kinds of chats that I would want to do? One is, I just like to talk to people, you know, whether it's on a telephone or the internet or a ham radio. So the chat modes. Just want to get on, call CQ, CQ, someone answers. I have no idea who they are. Oh, hi. Where do you live? Oh, blah, blah, blah. You just get to know people all over the world. Sometimes it's in more than one language, too. It's kind of interesting. So the chat modes, PSK31 was a great chat mode. CW, of course. I think the most fun conversations I've had in the last 2 or 3 years have been on CW. Sometimes they're about CW, but they're still fun conversations. RTTY, MMSSTV, I'm not going to talk about that. That's sending images, pictures. The DX modes, I want to work the world. Well, no question. The JT modes, FT8, FT4, CW is still popular to work DX. Even PSK31, but by far a long shot. I mean, like, 10 to 1. FT8 is wiping out the other digital modes because, hey, it's so much more efficient. I wouldn't say it's better. I certainly wouldn't say it's more fun because it's kind of after the 100th contact. For me, it was very boring. I go CQ, CQ, and I listen and I hear all kinds of stuff in the speaker, and my computer picks out a call and I click on that and I work them. I think, oh man, look, I worked Australia with 10 watts. Okay. I don't know anything about the person I was talking to. I just worked them, or I should say my computer worked his computer or her computer. How about contesting? Well, I did a little of that. That's boring for me too. Everybody gets on, you QRM each other. Field day's kind of fun. At least you get out in the fresh air. You get caught in the rainstorm. Who knows what happens field day. You often eat great food, best cooks. So the contest modes, RTTY, CW, FT4, FT8. And then what I've gotten involved with in the last 10 or 20 years is the emergency communication modes. So in an emergency, we're certainly not going to pick up a microphone and start talking about, I need this at my shelter and this and this. And, we can send all this as a spreadsheet on digital mode. So these are the different kind of QSOs. I spend most of my time either chatting to people I don't know or MCOM. I don't do so much at my stage of life, do the DX modes. I don't go on DX expeditions. It's fun to work them, but I don't do them. I once worked a guy down in the South Pole, and this was on 20 meters, and it was on single sideband or voice. And he said, do you live near Princeton, New Jersey? I said, well, Philadelphia, yeah, it's like 50 miles. He said, could you call my mom for me? My mom lives in Princeton. I haven't talked to her in almost a year. I would love it if you'd run a phone patch. I said, oh, I can run a phone patch. I've got a phone patch gadget, so what's the number? So I call her. Now for her, it was like midnight, so I call, she answers. I said, please don't hang up. This is your son calling via I'm a ham radio operator. I explained what I'm doing. And they had a great conversation, and he thanked me. He said, would you call collect? I said, no, I'm not going to call collect. So anyway, it was fun to be part of that. So that was a thrill because, you know, I got to help someone out. So a lot of these, the digital modes work easily, but for different purposes. So let's take a look at voice and a microphone. Well, we all know what happens. The voice is some, you know, sine wave type of signal. Da 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 da. You can sing, you can talk, you know, whatever. That merges with a carrier, and what comes out is the envelope shifts. Amplitude modulation, AM. So an easy way to do voice communication. So what happens when you throw a microphone audio into an RF carrier? You get a mixing, and the mixing produces some new waves, a lower sideband and an upper sideband. Now, as we know, the lower and the upper are identical. You don't need to transmit both. That's kind of inefficient, takes up more space. How about the carrier? No, there's no information in the carrier. So if we eliminate one sideband in the carrier, we have what we now call upper sideband or lower sideband. Much more efficient. We don't get as much interference, half the bandwidth, more of the power in the radio goes into communicating. Great. Now what if we do the same with a digital mode instead of a microphone and a human voice? That works just as well. So what is CW in terms of, what makes CW a digital mode? Well, I think of CW as zeros and ones. I don't know if you think of CW as zeros and ones. When I say that, the most common answer I get is, yeah, it's the dits and the das. You know, no, that's not really true, because in CW, to separate the dits and the das, what do you need? Silence. You know, dit. That's S. Da, da, da. You know, that's an O. But between those, there has to be a space. So what makes CW digital is there's either sound or no sound. So you got to be careful here. CW, if you send it rapidly enough, fast enough, the RF wave goes on, stays on for a bit of time, and then goes off. But it's not instantaneous. If it were instantly on and off, it would sound like click, 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 like a light switch going on and off. So the ideal here is turn it off reasonably quickly, like 4, 5, 6 milliseconds. And that makes the sound at the other end kind of sweet, and you don't hear the clicking. And it also doesn't sound like daw, which I used to hear. So here's some CW keying bandwidths as advertised on the magazine QST. And this is phenomenal, but they do this test at 60 words a minute. I'm thinking, ye gads. And what's the shape of the CW signal? So this is obviously, you know, picked up by a computer. And you can see some of the CW signals are very narrow, even at 60 words a minute. Some have tails, some are quite broad. You know, look at this one. So the question is, the better CW transmitters will transmit a cleaner on-off signal. So the listener at the other end doesn't have to hear a lot of extraneous sounds, harmonics, whatever. I thought, well, you know, when I was a kid, there was mostly CW and AM. There wasn't much of anything else in the 1950s and 60s in America. And today, I don't hear as much CW, but it's not dying, it's not dead, but there's not quite as much because there's more variety. So I thought, well, let's take a look at 40 meters during a CW contest. And look what I see here. So here's a SDR spectrum view. Now this is the RF. Over 40 meters. 7 megahertz is down here. 7.1 megahertz is here. So here's 100 kilohertz bandwidth. What do you see here? Lots of peaks. These are loud signals, right? S9 plus. Here you see them on the waterfall. Very loud. But notice they're all between 70-30 and 70-50. Why? All of this is a digital subband. Why don't these guys spread out? That's a good question, isn't it? They're all kind of huddling together, like, you know, QRMing each other. Why don't they spread out? Well, if they go too far low, they go into what's called the American extra part of the band. They can't do that unless they're, you know, the extra license. And if they go up higher, 70-70, they get into the FT8, WinLinks, you know. So they kind of huddle here among what, maybe 30-40 kilohertz. That's kind of, you know, squeezing everyone in your passenger car into smaller and smaller airplanes. And we know what happens when you do that. People get rude, you know, you interfere with each other, and, you know, this is a contest, so it's really a challenge. So I stopped working the contests with CW. I was getting a headache. So what makes CW binary? Okay, so I'll claim 0 means silence. The 1 is sound. Ah, it's not the dits and das. It's silence or sound. Now, how about if we say the dit, the letter E, 1 dot dit is just 1. So how about the da sound, like T, da, is just 1, 1, 1, no zeros. So it's a longer sound. How much longer? Well, 3 to 1. So that's kind of conventional, right? The das are represented by 3 dits. Okay. How do I represent silence? I just put a 0 in. So now let's take a look at our alphabet. So E is 1. What's I? 1, 0, 1, meaning what? Dit, dit. The 0 is the silence. S, dit, silence, dit, 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 dit. H, dit, silence, dit, silent, you got it. The T, there's no zeros. Da. The M is 2 dashes, right? But there needs to be silence between them. So the 0 is the silence. Da, da. How about O? Da, silence, da, silence, da. So you get the idea. So if I'm generating, a computer code, I have to think I'm just making sounds and silence. Then I have to sort of set the speed at which it goes, 5 words a minute, 20 words a minute, whatever. So how do you differentiate between a letter and then the next letter? Well, you need more silence, and we all kind of do that instinctively. So if you have, let's say, 3 zeros, that's a longer silence. So if I go da 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 da, I just sent CQ. If I listen to a lot of the new operators and I hear da da dit 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 da dit, dit, I get confused because I don't know where one letter starts and the next letter begins. So I learned CW from a real pro, about 25 words a minute. That's the way I learned it. So da dit did it. And then I learned combinations, QTH, name, stuff like that. So I really, when I listen, if I close my eyes, I hear words in Morse code. I don't hear letters. QTH, QTH. Well, we all get used to CQ, CQ. So this is the way most of us start. I still have my hand key. I need to polish it. It's getting kind of corroded there. So that's the simple way to send a digital mode. Send an RF carrier on, off, on, off, on, off, and try to time it reasonably well, CW. I had one of these as a kid, and I never could master it. They called them bugs. I don't know if that translates to English, bugs. You push the paddle one way, and it goes dit, 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 dit. It's just a mechanical rocker. But you have to do the dashes manually. I never could master that. And when I tried that, I was more or less sending da, 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 da. Like the timing was awful. So I've seen some people really good with these, but I'm not one of them. I saw this on the internet, and I thought, man, is that cool. Look, there's 3 types of keys. The straight key, but this is really machined well. And the paddle, then you connect it to a keyer. And here's an older style, mechanical key. I think whoever designed this and makes it, is probably selling it for a lot of money. That's one beautiful piece of equipment. So what does CW look like on a spectrum analyzer? I thought, well, let's catch W1AW, the premier American ARRL station. So I'm tuned up on 3581 kilohertz, 80 meters. I'm about 300 miles. So, man, look at the 50 over 9 on 80 meters with my 80 meter dipole. How broad is this signal? Well, that's a silly question, isn't it? Well, if I look at just the first 10 dB of signal, it's about 50 hertz wide. That's a nice clean signal. But as I get fainter and fainter, in other words, the vertical axis is fainter and fainter down to my noise level here. It's a broader signal. Well, it has to be. I'm listening to fainter and fainter RF and fainter sound. But that's about as clean a CW signal as you ever get. At whatever they were sending here, maybe 20 words a minute. A clean, nicely sent CW signal is maybe 100 hertz wide. I could narrow my receiver down to 100 hertz and clearly hear the da 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 da. The other way I can send CW not with a key is I just type my letters on my keyboard and FLDIGI makes a sound. Well, you just heard that, right? So I take CW. If you heard that out of your speaker and you're familiar with Morse, There we go. CQ, CQ, K3EUI. Well, that's not a hand key. That's not a keyer. What if my radio... All right, enough. What if my radio is not in CW mode? What if it's in sideband mode, like upper sideband? And I just pump this into the microphone. What happens? Well, the radio treats it the same as it treats my voice. Moves it up to an upper or lower sideband on 20 meters, 40 meters, 80 meters. What goes out? RF, going on and off, on and off. It's identical to you putting your radio in CW and pushing your key up and down, up and down. It's keyed RF. Identical. As long as, now be careful, as long as my microphone circuit is not overdriving. In other words, for those that operate on phone, you want the ALC to be reasonable or 0. So I'm not going to get a 100-watt radio and turn up the mic gain until I get 100 watts out on modulated CW. But it works. I've had a lot of contacts where I'm saying to someone, is my signal clean? Is it broad? Do you hear any clicks or any, no, it sounds good, Barry. I said, okay, because what I'm doing is generating sound in a sound card and pumping that into a sideband transmitter. So what you're listening to is a modulated CW signal. And at the other end, they usually say, well, sounds good to me. Good, thank you. So it's another way of sending CW with my keyboard. Why would I want to do that? Because my hand's getting tired sending with it. Now, there are other ways you can send real CW, keyed RF, with a keyboard and WinKey or other things, but, All right. So what I did was tune my radio on 3581, and I can try sending with modulated CW, and I get the same kind of spectrum. Here's W1AW, true CW. Here's K3EUI, modulated CW. When I say modulated, the carrier is missing and one of the sidebands is missing. So it is, and I tried to adjust it so it's the same level, 40/9. That's a pretty clean signal. You get a little bumps down here, yeah, but that's, 50 dB down. I don't care about that. FLDIGI is a really beautiful program. It's free. I say it's free. FLDIGI, written by a guy in Alabama who's a retired Coast Guard officer. Brilliant guy. So you can set the speed, the filters, all kinds of adjustments you can make when you're sending CW. Let's get on with it. So how about frequency modulation? Okay, FM. Well, we know it works with voice, but it also works with what? Sounds, any sounds. So in RTTY, you just have two different unique sounds, D, 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 and then you vary them back and forth. And depending on the zeros and the ones, maybe the low tone 0, the higher tone's 1, whatever you do, all you're doing is what? Changing the frequency. Now you're changing the RF frequency, which means the receiver has to be tuned somewhere. So out of your speaker also comes D, 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 D. And that sound goes into your sound card, and through the proper software comes back out as, letters, numbers, and print. So the modulation is in the frequency or the audio pitch of the RTTY signal. There's no silence. Well, what does that mean? Well, in CW, when you go dot it, what happens between the sounds? Your radio's off, so your amplifier can cool off a little bit. So RTTY is 100% duty cycle. It's as if you took your key and just put your fist on your key and just let it sit there for 3 minutes. That's sending full power for 3 minutes. That might hurt some radios. FM is like that. So in RTTY, often the instructions on the radios are turn your power back to maybe 25, 30 watts. Don't put 100 watts out on RTTY because it's blasting all that power all the time. You might overheat your final and cook some things. So there's two ways to generate a RTTY signal. One is called FSK or direct, and one's called audio frequency shift keying, AFSK. They both result in RTTY. So when folks talk about RTTY, they're talking about a type of modulation. How you produce it doesn't matter. In FSK RTTY, your computer sends a data pulse, and inside the radio, it shifts the VFO, maybe by throwing in another capacitor, something. So the data pulse, like square waves, go in, and the radio shifts frequency by a known amount, usually 170 hertz. That's easy to do, but you need a separate circuit to do that. So if your radio has a knob that says mode and it says RTTY or FSK RTTY, that's what it can do. But a lot of the radios don't bother with RTTY. They just have upper sideband or lower sideband, or CW, or maybe AM. So how does that work? Well, you just put in an upper sideband or lower sideband. You feed the audio shifting, DD audio, into your mic jack, your data jack, and out comes a RTTY signal. Does the person at the other end listening to your transmission know how you're making it? No. Do they care? No. So this is an easy way to get any single sideband radio to operate on the mode called radio teletype, RTTY. Usually the direct RTTY involves fancier equipment, a couple $100 worth of stuff, whereas your sound card's built into your laptop. So I found some pictures of some old RTTY printers. This goes back before me. These things would literally, type. You watch some of the old movies and, like the teletype machines on the postal services and the news services. Click, 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 So some radio sending some signal and out comes, printed message like this. Mechanical printers. I found this on the internet too. This would be like a modern station in about 1950. Modern, yeah. So here's your teletype printer. Here's your receiver. Anyone know the name of that kind of receiver? If you can read this, NC303, and National, made in America. And here's a Collins transmitter. It's also made in America. My favorite microphone at D104. So very clever. You could send teletype messages and, whatever is being received gets printed out here. You can sort of tell from the manual here, it's probably a 1950s or so. By 1990, this thing was very popular, at least in America. The Advanced Electronics Application, AEA. It was called a PK232. Wasn't very large. It was kind of expensive. And this was called a Terminal Node Controller, a TNC. It was much, much more than just a, quote, sound card. This thing could do PACTOR, AMPTOR, CW, packet. Did I get them all? Anyway, could do multiple modes. So your computer really became just the terminal. You didn't need a smart computer. In fact, like what I'm showing here is an old IBM, computer. And it connected to your radio by a very special kind of a cable. And you could sit there and type on your computer or your terminal, and out would go a RTTY signal or a packet signal or a PACTOR signal or even CW. Very, very popular in the 1990s. Now I have to stop and say, my son was licensed in 1993, 13-year-old, and we got one of these for him, and he had a 20-meter radio and a little homemade antenna in a tree, nothing much except for this. And he loved to get on teletype. Why did he like to do that? Because he was a 13-year-old and he knew a lot of people who were hams wouldn't want to talk to a little kid. Anyway, he's on 20 meters, and one weekend he gets this contact in Argentina, and he yells, "Dad, Dad, I got Argentina!" Like totally. But, it was totally keyboard. So, after they exchange their name, their QTH, their call, what their radio is, this guy comes back, and he was Argentinian, but he was in English here, said, "I'm a lieutenant colonel in the Argentine Air Force. I'm a test pilot. And I test the AR-22 fighter jet," or, something like this, And he comes and he says, "What line of work are you in?" to my son. My son comes back on the keyboard. He says, "I'm 13 years old. I'm in 6th grade. I don't know what I'm going to do when I grow up." So I thought that must have been, like I would love to see the guy's face when he realized he's on 20 meters working DX to America. He's talking to a little 13-year-old kid. So that's the beauty of keyboard modes. You're not sure who you're talking to at the other end. Okay, so here's what RTTY looks like on a waterfall. Just looks like two lines. When you listen to them, it's kind of boring after a while. But you can sort of tell if it's clean or dirty RTTY by how fuzzy the sound is. At least I can. I always wear headphones. 45 baud, that means the signal's going back and forth 45 times per second. That's the equivalent of about 60 words a minute if you're typing. And the two sounds are 170 hertz apart, so you can clearly hear it. D-D-D-D-D-D-D-D. If I turn on my radio right now and try to find a RTTY signal, I probably couldn't find one. 60 words a minute is pretty fast. You've got to be a fast typist for that. There's a famous program called MMTTY. It's his name. It's Japanese. He gave it away. It's free. It has been updated a couple of times. It's still pretty old now, but it's a beautiful RTTY program. It's like opening the hood and finding there are 20 controls you can play with, and you can get all lost. All kinds of different filters and things. But if you just do the default for everything, it sends RTTY beautifully, and it decodes it beautifully. Of course, you need a computer to let this thing talk to your radio. So I thought, all right, let me listen to RTTY when there's a RTTY contest. And there was a RTTY contest. I forget the date here. This was a couple years ago. So this is my SDR from, here's 3500 to 3600. Here's 100 kilohertz. What do you notice at the bottom of the band? Oh, there's some stuff down here at the bottom, and then maybe a dozen CW QSOs here. Then what do you notice from about 3560 to 3600? Man, look at this. These are all RTTY stations. Well, most of them. I know right in here they're not RTTY. Do you know why I know that? They all stop at the same time. There's a gap here. This is FT8. But all these guys are radio teletype. Every 2 kilohertz you hear another one. So when do you hear RTTY stations in America? Only during a RTTY contest. Never, never, never. Like right now, if I tried to call CQ and RTTY, no one would answer me. So let me stop. That was kind of an overview of that part. Are there any questions about CW or teletype? They're the two kind of commonly. Most of us understand about that. So let's talk about bits, bauds, and speed. And I thought this is kind of cool because I recognize a lot of the physics formulas here. Okay, so what's baud? You always hear baud. Every once in a while you hear baud rate. That's kind of rate. Baud is already a rate, so you don't need to say baud rate. That's like, in books I see current flow. That's the same thing. Current's already the flow of charge. So if you say current, you're talking about charges flowing. If you talk about current flow, you're talking about charges flowing. It's like, that's redundant. You don't need to say current flow, just current. So baud is what's changing per second. Something's changing. The amplitude, the phase, something's changing. So baud. It's also called the symbol rate. That's easier to kind of visualize. In RTTY or in CW, there's only two possibilities, DD, or sound or no sound. So currently, at least for America, the rate is maximum on the HF bands 300 baud. And you might say, well, that's pretty fast, 300 changes per second. But there are ways you can compress and get a lot more information if you're allowed to go higher than 300. And Americans are not allowed at the moment to do higher than 300. Makes more sense to say a bandwidth limit, but we're not there yet as a society, a radio society. So here's some comparisons. CW, 20 baud, about 24 words a minute. So that's a reasonable speed. 20 baud, 24 words a minute. PSK 31, oh look, 50 words a minute. That's a lot faster, but it's only 31 baud. Just a slight gain in baud, big change in speed. Why? It's a different structure. So CW, there's a lot of silence there, right? So PSK 31 is a more efficient way, you might argue. They're both about the same bandwidth. RTTY, 60 words a minute, 45 baud. Well, yeah, it's a little faster, but it also takes up about 300 hertz. So Olivia 8500, well, that's 500 hertz wide and only 30 words a minute. So you see, there's no direct correlation between bits and baud and words per minute and bandwidth, because the modulation structures are different on each of these. My favorite for 80 meters, Thor 22. 22 baud, 78 words a minute. That's as fast as any of us can type. And it's about 500 hertz wide, so it's not too greedy. It's kind of our Goldilocks best size there. 8 PSK 1000F. We do that on 2 meters FM. Over 3,000 words a minute. Oh, man, that sounds awful in headphones, but 1,000 baud. So that's good for transmitting documents like emergency communication spreadsheets, American Red Cross forms. So I thought, let's bring this back to something we can all visualize. What's the difference between a bugle and a trumpet? You know, you put your lips on both, you blow, and you get sounds. If you've ever tried to blow a bugle, and I have, there are only a couple notes you can play. And if you listen to the bugle types of songs like da 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 da, they're only musical. They call them thirds and fifths. There's only certain sounds you can make. It's just like an end-fed dipole. An end-fed dipole works on one sound, fundamental, I mean one RF frequency, and then harmonics of that, same as a bugle. In fact, I look at a bugle and I see an end-fed dipole. What's where you put your mouth? That's the coax, the feed line. What's the other end? That's where the sound comes out or your thing radiates. But wait a minute, a trumpet looks like a bugle except it has some valves. What do the valves do? Oh, if you've ever tried to play a trumpet with 3 valves, you can play all 12 notes of the black and the white keys on a piano. All of them. How do they do that? You only have 3 keys. Oh, well, you can put them in combinations. And when you look at the trumpet, you see when you push down a valve, it makes it a little longer. So it's like changing the length of your dipole, right? Except you can do it very fast. So my question is, if you pick a digital mode that has more than 1 or 2 tones, can you send more information per second? Let me stop and see if that question is clear. If instead of sending RTTY, do-dee, what if I send a mode that goes dee-dee-dee-dee-dee-dee-dee-dee-dee-dee, more possible states, more tones. Can I send more information per second than I can with just 2 tones? Yes. What am I getting at? Oh, so it's not only the baud, it's how many bits of information are in each symbol. It's how many bits per baud. It's like, whoa, wait, what bits per baud. So let's take a look at this. So the 3 valves, every time you push one down, makes the extension a little bit different. So I can push 1 valve, or the middle, or the third, or 2, or all 3. So I can make different combinations, and they, of course, make different sounds. Why can't we do that with a sound card? We can. So more possible variations in the pitch, the note, musically, corresponds to these different modes. JT65, oh my gosh, what is the 65? There's more tones. There's like 64 or 65 tones capable. But each tone has to be at a different pitch, right? So what's true about JT65? It has to take up more audio pitch bandwidth. So there you get the idea. FT8, that's simple. There's 8 tones. FT4, there's 4 tones. Well, if I do FT2, I'm back to RTTY. So MFSK has lots of variations. 4 tones, 8 tones, 16, 32, and there's even an MFSK with 64 tones. But it's like 2 kilohertz wide. So what's true of all these modes is the information's in the pitch. So musically, same thing. The other thing we have to watch with the digital modes is how greedy are we going to be? How much bandwidth does each of these modes take up? Let's go back to original AM phone. Double sideband with a carrier, 6 kilohertz. It's like, yikes. That's a lot of RF occupied space. How about single sideband? Well, we eliminate one of the sidebands, eliminate the carrier. Now we're down to half of this, or maybe a little less. 2 to 3 kilohertz. So we can get more sideband conversations in the same, amateur radio band. How about CW? Well, CW is great because it doesn't take up much real estate. 100 hertz. Maybe 200 hertz. If it's lousy CW, 300 hertz. FT8, yeah, 50 hertz. It's like, that's why it's so popular. You can get a lot of conversations in a very small amount of space. FT8. The other ones that are greedy, MT63, 2 kilohertz. Like, Thor, MFSK, Pactor. Pactor is getting a bad reputation in America. They interfere with other types of communications. Why? Because they take up 2.4 kilohertz, and they're in the digital part of the band. So one argument is put all the Pactor guys together in the same frequency, let them QRM each other. So that's where we are now in America, and that's not working either. There's a brand new mode that came out in the last year or two called Vera. Jose, EA5, Spanish, HVK. Just brilliant. It's a gorgeous sound card mode, doesn't require very exotic equipment, and you can structure it so it's no more than 500, so it's a little wider than RTTY, or up to 2300 if you allow the real estate. The JT modes, I don't want to say too much about this. They're kind of special, but Joe Taylor is a special guy. He and I were both astronomers, and we're about the same age, and we both studied binary stars. Mine was a little different, but I had the pleasure in the 1990s of teaching at my school physics to Joe's niece and nephew, both really fun, brilliant kids. So I got to know him in a different way as, Uncle Joe to the kids I taught. If you've ever tried FT8, it's just, you don't need much power. You don't need much of an antenna. You may need a little patience. JT65 takes about 5 minutes to get a QSO. FT8, if you're clever and fast, you can get a whole QSO in less than 2 minutes. And FT4, if you're really clever and really fast, you can get a whole QSO in less than 1 minute. QSO means what? You've exchanged your call, your location, and your RST, your grid. That's it. I can't say, oh, how are you today? It won't work. There's a picture of Joe a couple years ago, obviously. More modern picture, he's retired physics professor at Princeton. I'm going to skip some of the JT. Oh, someone said to me once, man, 20 meters is dead. I'm not hearing anything. So this was June 9th, 2 months ago. So I thought, all right, I don't have a very good sophisticated 20-meter antenna. It's a little vertical. I put it on 20 meters, and I'm tuned into the frequency where the FT8 stations hang out. And I listened for about 10, 15 minutes. Everyone here I heard. Now, I didn't work all these, obviously, but I could receive stations from all of these signals. Notice they're all in the daylight. Well, it was 20 meters. As soon as the sun goes down, 20 meters closes. No, typically. So look at all these stations. Some up here in Iceland, some down in South America. So 20 meters wasn't closed. Maybe you didn't hear many voice signals. Maybe that's what that person meant. Here's what FT8 looks like on the waterfall. Kind of gorgeous. It all the signals that you see here. And there's a gazillion sounds. It sounds like, 15. It sounds like a cocktail party. 15 people talking at once. The software translates all of them. I see what everyone is talking about. Well, I see where they are and what their signal reports are. Man, I can't do that with CW. So, I don't know. Sandra, if you're listening on CW, can you pick up 2 or 3 conversations at once? I can't. I have to concentrate on one pitch. And during a contest, I hear 2 or 3 stations calling CQ, and they're slightly different audio pitch. And, man, I got to concentrate on, I just want this station or this one. And they all hang out at a watering hole where FT8 guys hang out. All right, this is my claim to fame. This was a couple years ago. So I woke up early. It was winter time, I think. I thought, let me see who's on 40 meters. It was like 5 a.m. I don't usually get up at 5 a.m. So I get up and I tune into 40 meters, and my antenna is a 40-foot vertical. It's just a piece of aluminum tubing with a couple of radials. And I see this CQ 40 meters, VK3 LDB. So that's Australia. So I thought, I'll give him a call. So I'm about 10 watts, 40 meters. Give him a call, and he comes right back. VK3 LDB, K3 EUI. I called him. I said, I'm at FM 29, Philadelphia. Oh, 10 seconds, 15 seconds later. K3 EUI, gotcha. VK3 LDB. I copy you at -13. That's not real strong, but it's not real weak either. I come back, VK3 LDB. This is K3 EUI, roger. And I copy you at 6. -6 means it's louder. Like 0 would be really loud, like S9. So we go on, roger, roger, roger. Oh, 73, 73. That's the end. So I can log VK3 LDB. Well, I did. In fact, when Steve Ford published his book on HF digital modes, actually I wrote most of the chapter for that. He put this in the book. Well, I thought, well, that was kind of cool. I wasn't even trying to work the world. I was kind of bored. It was 5 a.m. I got up. 40 meters was, so it was darkness for me and darkness for Australia. It was just about dawn for me and just, dusk for Australia. That was kind of fun. FT8. Now let's get out of FT8. Oh, so here's some different modes sending the same thing. I said, what if I want to send the Gettysburg Address? That's kind of famous in America. 1.6 kilobyte file as a text file. If I choose this mode, MFSK 16, it would take 4.5 minutes. I'm not going to do that. But look, the bandwidth's only 300 hertz. So other modes, MFSK 128, oh, I could send it in 36 seconds. Wow, let's do that. Oh, wait a minute. It's 1920 hertz, 2 kilohertz. Ah, that would be selfish. So you see, if I pick a mode that sends this stuff faster, yeah, it sends it faster, but the price I pay is more bandwidth. So this isn't sending a chat mode. This is sending text, like the Gettysburg Address, or a spreadsheet, or a picture. So I can use legally different modes, but I'm not going to get on 20 meters and send a mode that's 2 kilohertz wide. I'd get other stations saying, come on, you're a hog. You're a bully. So I was going to say, any questions so far? Because I'm going to wrap this up in 8 minutes here. I'm not going to go over an hour and a half. That's really crude. I could talk 3 more days, but I'm not going to do that. Any questions so far? Okay, so I want to show you what these look like on a spectrum or on an oscilloscope. So here's MFSK 32, very popular on 80 and 40 meters. 32 baud, that's reasonably fast, 120 words a minute. So I wouldn't do this as a chat mode because I can't type that fast. But I could send a file, I could send a picture, 16 tones. It's kind of fast. 16, that's what? 2 to the 4, right? 2 to the 4th power. Meaning what? There's 4 bits per baud, 4 bits per symbol. So right away, even though the symbol rate is 32 baud, I'm sending more information per second because of more tones. Here's what it looks like as a spectrum. Oh, that's kind of cool. Here's the information up here, and here's the what I call sidebands. You probably wouldn't hear this because it's down 20 dB. Yeah, my sound card sees it, and I can display it. But if you were listening to this on a speaker, you wouldn't hear this kind of stuff. It'd be too faint. Well, maybe a musician might pick it up. MFSK 128 is so cool you can send images. So here's my grandson a couple years ago with his favorite radio. And I sent this over 2 meters FM. Took about, 2 minutes to send this whole picture. Olivia, very, very popular mode on 40 meters. Not quite constant amplitude. You can see the amplitude shifting a little bit here, but the waves get crowded together because the frequencies are changing. Olivia 8500, 8 tones, 500 hertz. Here's the spectrum of that, much sharper because there's no side lobes. In other words, the sounds it's like a trombone. The sounds slur from one to the next. Dee, dee, which means they take up less bandwidth. It's sort of more trombone sound-like than trumpet sound-like. Thor, I love it. Incremental frequency shift keying, fancy word of saying the tone pitch isn't what the baud isn't what the character is. It's the change in pitch from one sound to the next. Which means what? If your receiver is drifting a little, you still get perfect copy. So Thor works even with old tube type gear. Has forward error correction, meaning a way to dig out the mistakes. And Thor can send images. Let me just see. What else? I'm going to skip some stuff here. Oh, so PSK. I didn't get to talk about phase shift. That's harder to explain, phase shift. I'm not changing the frequency. Changing the phase. What does that mean? I'm changing where in the wave we're looking, like the start and the middle of a sine wave. So if you send a square wave into a PSK modulator, what comes out is when the pulse goes positive, the wave changes direction. Doesn't change frequency, it changes direction. So PSK would look like this, 0s and 1s, but they're sent not by changing the amplitude, not by changes in the frequency, by changes in the phase. So here's a wave on the way up, and when this wave goes off, this changes direction. It's easy to show. How does it sound? It sounds like a warble, like a warbler bird. Wah, 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 like that. PSK, Peter Martinez, the creator, about year 2000. Why is it an advantage over RTTY? Oh, first, it can generate easily in a sound card. Not hard. Well, once you've got the programming, it's not hard. Any single sideband radio, it'll work. Well, actually, it'll work on AM and FM, but no one would do that. Typing speed, 50 words a minute. That's fast. Bandwidth, 50 hertz. That's fantastic. In other words, it's very stingy with the bandwidth required. You can send upper and lowercase. I didn't mention RTTY is uppercase only. So here's what PSK 31 looks like on an oscilloscope. So this is a time domain now. So the wave goes up, Level, level, no phase change here, up, phase change. But when the phase changes, notice the amplitude changes. So it's not just phase changing. When the phase changes, the amplitude drops to 0. Why? I asked Peter Martinez that in a long email, and he sent me a nice email back. He says, simple, to keep the bandwidth very narrow. If the phase change were to occur at the peak, when the amplitude is peak, then it would generate all kinds of harmonics and take up a whole lot more space, spectrum. So he said the beauty here is if you look closely, the phase change occurs when the amplitude is pretty close to 0. That keeps the bandwidth very narrow. It's a smooth, clean sounding signal. So here's what it looks like on a waterfall. Almost like two lines or a bright line. Every once in a while you see some parallel stripes. That would indicate probably the sender has too much audio. It's just two parallel lines, and the lines are so close, 30 hertz apart, 31 hertz, that it looks like one line. Here's what it looks like when I want to get a good spectrum of it. Here's the two sounds. They're separated by 31 hertz, so it's like a square wave going on and off, on and off. And then here's some harmonics, but each of these horizontal lines is 10 dB. 10, 20, 30, 40. So the next set of harmonics is 40 dB fainter than the signal. You'd never hear that. That's sort of like saying, in sideband there's a carrier. Well, there is a carrier. It's just suppressed 30 dB, 40 dB, 50 dB. It's not, 1,000 dB. So this would be a nice, clean sounding, very clean sounding PSK 31 spectrum. And of course it is, because I made it with my own radio. And you see here the received signal is pretty loud. All right, so let me end with this slide. So how can we send more information? Phase. It's hard to explain, except I thought of this. What if we think of, what's it called, semaphores? Flags. I have only 2 flags and 2 hands. What can I do? So I can move where these are. So this represents one signal, A. If I move one up, keep the other here, that's a B. Move one up a little higher, that's a C, and so forth. So all I can do is move the flags to different locations. Think of that as phase. And what have I got? A lot more combinations I can make with only 2 flags and 2 hands. That's what phase shift means. With phase shifting, I can change the degree to which the wave starts and stops. And if the software can decode that and still not take up too much more bandwidth, then wow, I can send a lot more information per second using phase shift keying. So what we usually think of as PSK 31, that's the bare bones simplest. There's 2 phases, on or off, 0 or 180 degrees, that's it. So it's often called binary phase shift keying, BPSK. In fact, that's what Peter Martinez used to call it, BPSK. So what if I send multiple carriers, each with its own PSK signal? Well, I can do that. See, here's a single carrier with modulation of multiple tones. Each tone has its own PSK modulation. Oh, well, that's getting pretty complicated. But it's like, instead of one train on one track, what if we have 16 parallel tracks and there's 16 trains going? All in different directions, all at different speeds. As long as they don't touch, they don't collide, no collisions. That's what this is. So if I look at a multiple PSK signal, and I'll stop at this slide, here's what it looks like. Yikes, look at all those stripes. Each stripe is a sound modulated at a PSK level of whatever it is, 31 baud, 50 baud. So what's the advantage here? I can send a lot more information per second. In fact, so much information per second that I can't type that fast. So this would not be a typical chat mode, but it might be a kind of mode where I could send a spreadsheet or send, something that was a lot of information. So let me stop sharing. I've got like 100 more slides, but I got to stop. See you guys again, and stop and say, all right, so it's 4 o'clock my time. That was an hour and a half, right?
It's 9 o'clock our time.
Yeah, so it's time for whatever you do at 9 o'clock. 9 o'clock here, we call it Quaker midnight. We go to bed.
Don't know, oh.
So let me stop and ask for questions or comments, or I got lost 10 slides ago.
Oh. Unmute your microphone, Alex. You're muted, Alex. unmute your microphone, Alex.
Just press the space bar if you want to talk.
Yeah, it should. No. Yeah, it should have unmuted permanently. No, it's that kind of time, all the way from Sky.
What? Yeah, 4 o'clock here. That's tea time, right?
Yeah. Interesting. Anyway, Alex, Barry.
Well, this is a mode I love. I mean, I could wing the whole thing, and every time I think I want to present on some topic, I think, oh, this might be interesting, and then the slides go from 20 to 40 to 200. I'm thinking, no. But it just depends on what you're interested in. The most common question, it was a good question, is why bother with digital modes? Just pick up a microphone and talk. Sure, talk. See how far you can get. I can get Australia with 10 watts with FT8. Let's see you get Australia on single sideband or AM on 10 watts and a homemade antenna. Give it a try.
Well, there's some interesting digital modes of systems back, because the Russians do one. Well, it's not really a contest. And you talk to them on one mode, that's the end of that conversation. Then they'll flip over to another mode.
Oh, not clever.
And then flip again, and then flip again until you can't.
Is it in a contest count as individual context if you change mode?
Oh no, it's not really a contest. It's
Activity.
It's waking up all the different modes.
Oh wow. It's like going
Yeah,
lower sideband and upper sideband, but you sound the same.
Yeah.
Yeah, it's set operating time. It's good fun though, isn't it, Dave?
Yeah.
When you run out.
Yeah, it's the trouble is the system I used, it doesn't do all the different modes that they do. So I end up getting so far through it, and all of a sudden I can't swap to their latest.
Oh, that's a good question. Yeah, when you hear a sound on you're tuning across 20 or 40 meters, you hear a sound and you're thinking, what mode is that? Usually look on the dial. The folks that are on FT8 hang around the same frequency. The folks on RTTY hang around a different frequency. The folks on CW, as Sandra knows, they go wherever they want. CW can go anywhere.
Yeah, I can't remember what it's called. Mike, if he's listening, he's hiding at the moment. I'm not sure whether he's there or not, because he's the one that G4SJX. He usually has a go at these.
I can tell from his slide there, it might be slow scan television. There's a mode referred to as MMSSTV. Well, that's the application. So I can tell if G4SJX does amateur television. That's certainly a digital mode, but it's sending an image rather than talking.
Yeah, I can't remember off the top of my head what the Russian group is called, but they every now and then again they have this digital sort of weekend, and I think they're in the middle of one at the moment. I'm not sure, but every day or weekend or whatever it is, it's a different digital mode. It's quite good. At least it gets people using all the different digital modes.
All right, so here's 20 meters again. Look at the CW part of the band, the lower part of the band. There's almost nobody there.
Yeah.
What are all those signals in the middle? FT8, 14074.
FT8 and FT4.
Any RTTY signals up here? No. CW signals down at the bottom of the band. I think I see one, maybe two. So is FT8 killing amateur radio? No, there's a lot of people talking to other hams on FT8. Is it killing CW? Probably. Why?
I don't know.
I don't know. I like to operate CW.
There seems to be a resurgence of CW. There's a lot more people starting to use it, I think.
Yeah, it's a challenge.
Barry, FT8, I've never used it actually, but it looks to me as though timing is fairly critical.
Oh, yes. Everyone talks at the same time.
Yeah.
FT8 at the beginning of the minute, and then at 15 seconds, 30, and 45. So your computer clock has to be correlated, synchronized with WWV to within about 1 second, maybe a second and a half. So everyone calls. Can I do that? Let me think if I can do that. I think I can do that. I can get on my radio on my screen here and share with you what I see on Zoom instead of holding my camera up. Let me try that. I've never done that, but I think I should be able to do that. So I have to close this. Oh, this is a challenge. Let me stop share. Did I stop sharing?
No.
We can't see anything.
Oh, that's good. I wanted to stop share. So I'll bring up FLDIGI. I should be better at this, shouldn't I? All right, I want to hook up to my sound card on the HF radio. Sorry for the delay here. Never done this before.
Don't do that.
All right, so now I'm looking at... Oh, no, I don't want that. I want... I brought up the wrong app. I don't want FT8. I want FT8, not...
I see you have a friend, Sandra.
Yeah. Bit too friendly at times.
It looks a lot better than the other.
Ooh,
He's probably looking for his supper, Sandra.
yeah. Oh, do that, naughty boy.
All right, I'm almost through here. Ah, got it to work. Now let's see if I can share screen. Did that come up?
Yep.
Yes, yeah.
All right, this is live. Let me turn on the sound.
Yeah.
Sounds awful. Look, listen to all these. Let's check out the spectrum. So I'm at the mode FT8, decoding fast. Let me erase. Look at all these stations I just picked up. Everything in green is a CQ. That was 15 seconds listening. Look at this. CQ DX, DM2, DXA. I don't even know where DM is.
Germany.
Ah,
Okay.
okay. This is on 20 meters. Oh, let me click this. Maybe I can work them live. IK5FKF. Where is IK? Spain? Let me see. I'm not even watching my radio. I think that was about 20 watts. Let's see if I'm going to get them. It's like, I'm not very good at this. This was at a pitch of 2400 hertz. That's pretty high. Nope. I'm going to call them again. That's only about 10 watts. Let's give them a little more power. 40 watts. Maybe that'll do it. Maybe I should try something. So FT8 is clicking here, clicking there, working a station. If I don't get them now, I'll try someone else. Yeah, I'll just halt. All right, let's try EA5KB. That's Spain, isn't it? EA5?
Yep.
Spain.
So I'm at 1757 on my waterfall. So on my spectrum, I can see. If I show you the spectrum here, I'm right about here.
Can't
Let's see if
your
I get this
spectrum.
guy. No, didn't get it. I better halt. So I can't talk over that either. After you get fast with the mouse and the keyboard, the FT8 program works pretty fast. But as you can see, in just a few seconds here, I've decoded. My computer has decoded all of this information. Everything in green, I think that's green, is a CQ. Up here, I have to tell it in settings some general things like what's my sound card, what's my radio, do I have a cat port, a COM port, what mode am I in? You know, all these are just settings that once you do once, you're good. Let me close this. Okay. I don't know if you saw that.
I should have
So
left.
the program is called WSJTX. Oh, did I say it's free?
I should have left the radio on. I only switched it off about 15 minutes ago.
So let me just go stop share here. Okay. So FT8, the application, the program is free. And it gets updated a couple times a year. There's a whole team now that develops it. All right, I'm back to seeing you all full screen. Just personally for me, after about 100 contacts with FT8, I was, what's the word, satiated? I got bored. Yeah, I could work stations with 1 watt and a dipole antenna in my attic. So what? So, you know, like, all right, I worked them. They're in my log. It made it too easy. I mean, Joe and I we're pretty good friends. I said, Joe, it's too easy to work the world with 1 watt and an antenna in your attic. He said, yeah, you know, try now moon bounce, Barry. You know, try to bounce your 1 watt off the moon on 2 meters. And I said, oh, no. All right. So, I mean, the software is ingenious because it picks out these signals that are embedded in the noise. I mean, they say a good CW operator, that's not me, a good CW operator, you can work when you're hearing the sound at about the same level as the noise you're hearing. So the signal to noise is about 0 dB. The noise and the signal are about the same sound in your ears. Okay. FT8 works down to, I think, negative 20 dB. Negative 20? The sound is 20 dB less with FT8 than with CW. But it's not a human, you know, listening to FT8. It's my computer.
Yeah.
So my sound card is better than my ear brain. But I have more fun with CW, so I like to operate CW.
Yep. We shall have to look forward to part 2 now.
Well, part 2, I was going to talk more about the emergency modes.
Oh,
Because
right.
there you want to be both fast and accurate.
Yeah.
And the big one is Pactor and Vera. Not so much Packet anymore. Packet goes back 40 years. Packet's good for local stuff on FM radios, but nobody uses Packet on HF. Doesn't translate well. But Vera is free. I mean, the nearly free. Simple sound card. I think to buy a Vera license now is like $70.
Never heard of it before, so it's a new one.
VARA. Well, let me just say Google VARA. That's the mode. It's called Vera rather than, you know, like PSK, CW, Vera. The author is EA5HVK, Jose, Spain. I've had a lot of personal email back and forth with him in English because I don't speak Spanish. And he answers everything, all the questions I pose, technical stuff, he answers. So he's very good. But he doesn't give away his product. Site licenses. If you're a club and you want to buy a license for your club, I think it's $50 American per person. But the software, WinLink, is free. Oh, they badger you for money. Do any of you operate WinLink at all?
No.
WinLink is very popular for worldwide communication when there's a disaster, like in Haiti. It was just a earthquake. If they lose emergency communications, telephone, cell towers. Puerto Rico a couple of years ago. A couple of hams with a couple of radios and wire antennas. You can work signals back to North America somewhere, and get on the internet and get communications all over the world easily. With let's say 20 meters and PACTOR, 40 meters for more local, Caribbean messages.
I can't remember his call sign now. He does a Pi build for amateur radio, and he's got WinLink amongst other things in the build, which is pretty good build for the Pi, but it's got all sorts on it, but I can't remember.
So WinLink or RMS Express is the overall package,
Yeah.
but then the modes, like CW already, the modes are called RDOP and WinMore. They're the older ones.
Yeah.
PACTOR, Packet, and now Vera. Vera's just joined in the last year. So it's a brand new mode. By far it exceeds the other modes in clarity, speed. It's just very clever modulation techniques. Still within the human audio bandpass. It's not that it takes up, more frequencies than the other modes, but it's more clever modulation scheme. Questions? Comments? Did I aim that too high, too low?
No, that's something to have a go at. We'll have a go at that, whatever. We can find, because it implies that you can use a not such a good version for free, so I might have a play.
If I wanted to dabble in one program and just try this, I would get FLDIGI. FLDIGI.
Yeah, I run it all the time.
That's how Alex does his CW.
Yeah.
He's a
I mean, the
keyboard
old
warrior.
ones were like Ham Radio Deluxe, HRD, has a lot of modes, Mixed W. There are a whole bunch of applications, often you have to pay for them, that do a specific mode or a combination of modes. MMTTY does exclusively RTTY, but very well. FLDIGI, the nice thing is designed for emergency communications as well as just chat. And I can get on FLDIGI and get on CW and talk to anyone who's sending anywhere from 5 words a minute to 30 words a minute. And if the sender is sending clean CW, well timed, on my FLDIGI receive screen, 100% copy. I may miss a letter too, my computer doesn't. Like if I listen to the W1AW code practice bulletins on 80 meters, because I get them easily in Philadelphia, 100% copy. Do. I was taught when I'm listening to CW, if I lose a letter, don't worry about it. Don't think backwards. What was that? Just listen to the next letter, because most of the time you're hearing words. So I just want to know what's the word. I never write anything down, by the way. Well, if it's a contest, I've got to write something down, or I'll write maybe the call letters. But I just listen as if I'm talking to you. If I'm talking to you, I don't write down what you say. So in CW, I try to listen to what someone is telling me.
Your brain fills in all the blanks, doesn't it? Because I think
After a while,
is, as long as you get the first and the last letter of the word, your brain will fill in the rest of the word.
If someone slows down to like 15 or 12 or 10 words a minute, I'm lost. It's like the lookup table is missing. I can't, I learned like R. R is did-a-dit. It's not did-a-dit. It's like...
There's a pattern.
Sandra's
Alrighty.
It's music.
It is.
It's music.
Do you work CW with headphones, Sandra?
Yes.
Yeah. Because then you don't distract other people or your cat or.
Yeah. That's right. Yeah. Well, thank you very much for tonight, Barry. It's been great, very interesting. I've learned quite a bit with the different sounds of the different modes. So yeah, it's been very good. I'll listen around the bands now, see if I can hear any for good. For real.
So on 20 meters, 14074. That's the famous FT8. Oh,
Yes.
I should have said they're all upper sideband. None of these
Yes.
modes are lower sideband. They're all upper sideband.
Yeah.
Even on
I've-
80 and 40 meters, it's upper sideband.
I've been using FT8 quite a bit. I didn't think I'd like it, but I do. I quite like it. Especially if you've only got 10 minutes or something and you just want to listen
yeah.
to a bit of radio. It's easy.
Sometimes
it's
I'll
good.
go to sleep and leave my radio set on, let's say, 40 meters or 80 meters, because I know at night they work well.
Mm.
And so I'll just
Yeah.
let it run for 6 hours. Then I get up in the morning and scroll through and see all the stations I heard. It's kind of fun to see. Oh, look, 40 meters was open to Australia or Japan
Yeah.
or,
You ought
Excellent.
to change it to whisper and leave it on running
oh yeah,
on whisper.
that's even better. Yeah. Whisper copies like to negative 28 dB or something, like that.
And more.
Yeah, yeah.
Excellent. Good.
And the power levels they're using are quite minute, some of them.
Yeah, it used to be that if you were an FT8 with more than 10 watts, you were, power hungry. 10 watts was as much as you ever needed. And now I hear some stations say, oh yeah, I'm going to get on FT8 and I want to work, Cambodia with my kilowatt. And I'm thinking, oh man, it's like driving 120 miles an hour on your highway. It's like, get out of my way.
Anyway, good